Respected dignitaries and friends from various continents, good morning and good afternoon, as people from all parts of the globe are assembled here. Let us first congratulate the technology that made it possible, and of course the technicians. And today's topic is about the fast developing technology, artificial intelligence, machine learning, and related matters. The program is jointly organized by Center for Information and Guidance India, CIGI, with headquarters in Calicut, Kerala, and EXL-UK, based in UK. Let me welcome you all to this wonderful and most useful event. The program will be inaugurated by the President of CIGI, Mr. P.A. Abdul Salam. It follows talk introduction by Dr. Riaz Abdullah from EXL-UK. Keynote speaker is Mr. Abdul Salam Kunnummal, topic artificial intelligence and machine learning. There is a question answer session after that. In addition to Mr. Abdul Salam Kunnummal, Mr. Mujib Parambat, Mr. Asim Shah Tachamboy, Dr. Siddiq Punakal, Mr. Nemshid Hashim, Mr. Rubas M. Kuti will also be in the related programs. Let me welcome all the experts, CGNs, and students who are eagerly waiting for the session. Now over to Mr. P.A. Abdul Salam, respected President of CIGI, for introductory remarks and inauguration of the program. Welcome, sir.
Thank you, Secretary sir. Assalamu alaikum. Respected moderator of this webinar, Dr. Riaz Abdullah and Dr. Siddiq Ulaikal. By profession, they are doctors, but by passion, they are committed social leaders, so you can say. Yesterday also, in fact, we had a program initiated by them. And again, all the beloved students and their supporting parents, my dearest team members of CIGI, Career Division, and fellow CIGIans. First of all, I extend a warm welcome to all of you who are assembled here to view a program on artificial intelligence and machine learning. Looking to your faces, probably in this small frame, I can see a cheerful and pleasant face in all of you, and even I can imagine that all of you are happy and inquisitive to listen Mr. Abdul Salam Kunnummal. Suppose, or had it been this event on a COVID-19 talk, I think the faces would be different. It would have been different. Your lip curve, U-curve should have been ulta and slightly tensed and with some anxiety. So we are going through a situation which is, of course, some anxiety and some sort of fear always we will be having. But in fact of this situation, we can see that there is a brighter side. We have to look into the brighter side of this crisis. CIGI stands for showing you the brighter side. Many a time in our life, we have to pass through the tunnels of crisis. But at the end of the tunnel, there will be a beacon. In that light, we can see some ladders. In fact, CIGI is showing ladders to the students and youth. If they climb through ladders of their choice, they can be successful in their life. So that is exclusively the business of CIGI. Business in the sense it is a non-profit business. CIGI, a NGO, a non-profit NGO, is in the service, is in the social work for the last 24 years. We are having broadly 3 types of services. One, the information services, mainly doing through our career division. They are giving career information, course information and all. And again through our journals. The second one is our intervention services through our projects, our 24 projects. These are our ongoing projects. We are giving certain interventions based on specific goals within a time-bound action plan. We are having this program for different segments of students, different segments of institutions, and this also having specific target and specific time period. And third and most important service is transformation-based service. This is to provide an extensive long-term support system to students or the beneficiaries to transform their life, their quality of life or their study habits or what sort of goal we are setting. So the transformation focused service is meant for that. Here in this period of COVID downtime, we have shifted to technology again. On fast track, we are moving with the cheese and adapting to the technology, and we are conducting a variety of programs to reach out our beneficiaries. This career division conducted a lot of variety programs, and this is one among that. And this Tech Talk, partnering with the EXL-UK, is first in this series. And I congratulate the team of Career Division for initiating from our side to launch this program. So here, our Career Division is always looking to outside, or they are scanning the emerging trends in the job market all over the world and bringing the various career scope to the students and youth and updating these programs regularly. Even the pre-COVID situation, we used to advocate this sort of technologies, especially this advanced technology like artificial intelligence, machine learning, blockchain, etc., which world over people used to describe as the disruptive technology because of its groundbreaking impact. But what happened, we know, subsequently due to the COVID-19, the disruptive pandemic, the situation has changed. Pre-COVID stage, when we talk about the disruptive technology of AI, we used to say that some of the career is going to be vanished because of this technology-driven situation. Now situation changed. Due to the pandemic-driven situation, many of the jobs, irrespective of the segment or sector or technology, it is going to disappear. Now we are in this context, we are discussing the artificial intelligence once again. Probably a lot of concerns, lot of doubts will be in the minds of the people and students. What will be the future of artificial intelligence in this COVID situation or post-COVID situation? We want to listen from Abdul Salam Kunnummal about different aspects. What will be the application relevance of AI during the post-COVID situation? Or what will be its relevance? What will be its impact? How it is going to recoup in this crisis situation? These aspects also, I hope, he will touch upon during his talk. then we are fortunate to have an expert faculty, expert speaker, Abdul Salam Kunnummal, who is having over 22 years experience. He is an IT solution architect, and his name, the suffix Kunnummal means in Malayalam, on the hilltop. So he is on the hilltop of this particular topic, and he is an expert on this. We are looking and want to listen from him, but one thing is sure, we are fortunate or unfortunate to live in an era where we are transferring some of our cognitive skills, like learning, like auto-correction to some machines and robots. Why I said unfortunately, we are not quite sure about its social impact, probably career impact we can say. Anyhow, if world has invented something new, which is yielding result, so long as it is yielding result, it will continue, and we can hope this will have great scope in our life. So sitting in the valley, we will listen to Abdul Salam, who remains in the hilltop of this expertise of this particular subject, and we can then decide. I request the students, you can decide whether this ladder is fit for you. If the ladder is fit for you, we are here, CIGI is here to help you to climb to the ladder, and what are the other things you have to do. If it is not fit to you, of course, there are so many ladders. We will take you through this journey to see other options. So there are hundreds of options in the world, and the future is bright, very bright for you. Be hopeful and optimistic. And with this small words, in the name of God, the benevolent, the graceful, I declare this program as inaugurated. Take care, all the best. Thank you.
Thank you, sir. Now, talk introduction by Dr. Riaz Abdullah K. Please, sir.
A big thank you to CIGI and all of you. Assalamu alaikum. Good morning, good evening, good afternoon to wherever you are. It's indeed a great pleasure to introduce this talk. First of all, I'd like to say a big thank to Mr. Salam, Mr. Zakaria Saib, and all the other people behind the scenes within CIGI who made this happen. A part of this program, what we're trying to do is to share our knowledge and message across the continents. We have experts in India, we have experts in the United Kingdom, and our main aim is to spread this knowledge across the spectrum. Now, just to let people know what we do as EXL-UK. EXL-UK is an educational charity in the United Kingdom, which is formed by a group of professionals based in Kerala. We are part of the Kerala Association of Muslim Professionals, who have been functioning for the last 6 years, involved in a lot of charity work, and EXL-UK is educational wing. So we deal with the medical education, medical careers, technology, finance, business, and all the other various disciplines. And our main aim is to provide support to our local partners and partners across the world to promote education and training and careers. So that's what we do. Now, coming to the actual talk of the day, we know the relevance of machine learning, artificial intelligence, automation. As a doctor, I think I'm just getting familiar to these concepts. But the world over, this has grown by leaps and bounds. In fact, in healthcare, the robots are doing surgery. In healthcare, is all automated systems in which we provide remote blood pressure monitoring. I know the cars are going into automation. So this is a big area which is developing. And of course, for big things, we need big people to talk to us. And we have one of the best people in the business here. It's Mr. Abdul Salam Kunnummal. Now, Salam is well known to us. He's an active member, executive member of our EXL-UK. But more than that, he has been in this industry for about 22 years. He's an IT solutions architect. He's got a master's in computer applications. I think he's got a huge profile. So we're just telling basic minimum stuff. He's worked for renowned companies like HAL India, Siemens UK, Mercedes-Benz in the United Kingdom, and NS&I in the United Kingdom. He's got a lot of certifications, including Google Authorized Trainer, Google Certified Architect, and Amazon Web Service Architect Professional. He's designed our websites. He's done a lot of things. He is speaking around the globe most of the time, and he's quite a passionate IT trainer into his area. So without any further ado, I would like to invite Mr. Salam Kunnummal, Abdul Salam Kunnummal. Salam, over to you, and a big welcome to you all again, and hope you enjoyed the talk. Just before I go further, I just want to say the format of what we're going to do today. What we're going to do is we're going to have the inaugural talk for about 30 minutes, for about 50 minutes to an hour at the most. And after that, we have a question and answer session. That is going to be a dedicated question and answer session. First we'll deal with Q&As related to Salam's talk. Then after that, we'll have a lot of other experts related to automation within the sector, and also some general IT queries. And we'll go on to that, and then we'll take your questions. So though our talk time is 2 hours, by experience, we did one webinar yesterday. We ended up having 3 or 4 hours because of the interest that was there. So feel free to come in and go out as much as you can. And I think without any further delay, Salam, over to you, Salam.
Thank you, Riaz. That was a very, very generous introduction, I think. See, I'm not that, expert as he spoke about, but I've been in the industry for a while, so I thought that the whole idea of this one is, to give something back to the society where I come in. And I'm always a believer you have to give something back to the society, because I never think I'm here because of, it's because of me. There are lots of other elements which help, including the shops, the shopkeepers, the people who help me to cross a stream, and they are part of my journey. So I had to give something back. So ignore whatever Riaz has said. So before I start, I would like to order some food. Haneen, are you there? Haneen is, by the way, my daughter. She's studying for law in University of Kent. So she will be my assistant today. So can you all hear me all right?
Yeah.
Yes, Salam.
Okay,
yeah, we're good, Salam. We're good, Salam. Yeah.
Okay. Haneen, are you okay?
Yeah. Hi.
Hello. Can you share your screen?
Mm-hmm.
Okay. Hello. Assalamu alaikum.
Walaikum salam.
Okay. Share your screen, and can you order some? And don't forget my favorite biscuit as well. Okay. This is a system which we order food in the area we do. It's called Starship, and I'll talk about it a bit later. So you got hot food as well, I get, Haneen, is that right?
Yeah, so there's a pizza place, there's burgers.
No, I don't want all of that in the morning. I just get some biscuits, and you know what my favorite biscuit is, yeah? So
yeah, just something from the supermarket, yeah?
Yeah, that's true.
There we go.
Okay, cool. And you got enough money to pay for that, I guess, yeah?
Yeah. We need some bread and milk as well, so getting those too.
Okay, cool. Don't give away the credit card details, yeah? There are quite a few people.
There we go. It should get here in about 50 minutes.
How long?
50 minutes.
Okay, so if it is around close to our house, just let me know, yeah?
Of course, yeah.
Okay, thank you, honey. Bye.
Thank you. Bye-bye.
Okay, so that's out of the way. So hopefully I'll get some food in between. Okay, so as most of the people spoke here, I'll be talking about some of the hot subjects. There are a few people waiting in the waiting room. So can you admit it? It's kind of coming on my screen. Okay. So as people said, I'll be talking about mainly the artificial intelligence and machine learning today. And as you know, this is some of the hot topics these days. So what is the agenda today? So I'm within an hour, I don't think I'll be making an expert in this area. So what the agenda is, I mean, I don't have a fixed agenda. It's basically, there are loads of jargons thrown around in this industry, like machine learning, deep learning, artificial intelligence, algorithms, cyber attack and self-learning and all of that. So this is just to demystify, what is what, and just give you some pointers so you can decide yourself whether you want to go that direction or not. I'm pretty sure, if I can get at least one person interested on this one and follow that path, I think I have done my job. That's my belief. Let me just minimize that. Okay. So yeah, so without, I'll just, go one by one. So my slide set is, might not be useful just by its own. So it'll only have some pointers which I can talk about. Yeah. So if there is any questions, obviously you can put it in the chat window, and there's a panel of experts who will try to answer those questions as and when they come in. And if there is anything specific to me, you can just mention my name as well. Okay, I'm sure you know these guys. He is a quote from Sundar Pichai, who is the CEO of Google. He says, AI is probably the most important thing the humanity has ever worked on. And if you look at that, it's a really profound statement. I mean, most of the, these are normally used by, the people in the pharmaceutical industry or in the health industry and people like that. But a technology industry is speaking about the humanity, and that's quite interesting, which is why I put that in. And this could well be true. I mean, this will touch pretty much every aspect of our life. And this is another quote from Stephen Hawking, which, as you might know, he's a physicist who was working in University of Cambridge, which is about 40 minutes that way. It's quite close to me. I live in between kind of Oxford and Cambridge. Cambridge is around 40 minutes this way, and Oxford is about 40 minutes that way. So. So yeah, he's a professor of, as you know, he was not able to walk. He had lots of problems, but this is one of his statements. So AI is likely to be either the best or the worst thing to happen to the humanity. And, in some way it is, as Salam sir said, it could, just like any other technology, Facebook, there are 1,000 good things happen with that bit, including the Arab Spring, and loads of good things happen. There are lots of people getting money for the charity and stuff like that. But on the other side, there are people who committed suicide because of the peer pressure coming from the Facebook. It really depends upon how you want to use the technology. And what Stephen Hawking is saying is, actually, if it is used for the good, it will going to be, the best, or could be the worst thing as well at the same time. Okay, this might be quite interesting. You might be thinking, actually, why is he doing it? Is that a wrong slide? It's not a wrong slide. Basically, I'm going to tell you a story, and probably then it will kind of become a bit more clearer. So this is something happened in USA. There was a 1 second. There was a single dad living with her 14-year-old daughter. And they were getting loads of vouchers for baby items through the post. And this guy was divorced from his wife for about 10 years. So he got these vouchers, and he was thinking, why, these vouchers, which is, my wife hasn't been living with me for some time. So he called the company was Kmart, and called them and said, see, it looks like you got something wrong. I'm getting loads of vouchers for baby items and pregnancy care and stuff like that. And they looked at their data and said, sorry, it looks like there's a mistake, and they have corrected it. A few days later, it started again. The guy got really annoyed because somehow, probably he didn't quite like the remembering his wife. So he got quite crossed and called them and again said, see, you had to stop doing this. My wife is not here. We have been separated for some time, and I don't want these vouchers to be on my doorstep, and they looked at the details. They said it could be something wrong with our system. We'll have a look, and they looked through the system and said, we'll come back in a couple of days' time. So they looked at the system and called them back in 2 days and said, sorry, sir, it looks like your daughter is pregnant. So that's where the penny drops. This is how the technology is going. So basically, the story is actually this: a big company knows somebody's pregnant before her father knows about it, and that's quite a scary thought. If you elaborate it, there will be quite a few things we don't know when others know. There was another story which I can tell personally. I booked a ticket for a cinema with my daughter about a few years ago, and I haven't booked. It was nothing to do with the Google. I booked through the normal system and their booking system, and I got a pop-up about 20 minutes ago saying there's a traffic between now and the cinema. You may want to start now, and that is these are all quite a there is nothing called privacy anymore. So they are getting data every time. So before we go to the machine learning, I hope that that story is clear. So before we go into detail about machine learning, let me just move this waiting. You may want to disable that waiting room or something. I can see a pop-up on the top all the time saying "see waiting room." Okay, so how do we learn as human being? It's called a walk. It can be either visual. I'm a visual learner. You have to see something, then you can learn about it, or it's auditory, which you hear something and learn about it, and read and writing. That's another way. Some people like to do that. And if you look at take the first letters of each one, this is the easiest way to remember. It's called WARK, W-A-R-K. And kinesthetic is obviously touch and feel. Even if you're blind, people learn by touching and feeling. But now we'll move on to the machines, and how about the machine? How do they learn? There are something called supervised learning, unsupervised learning, and reinforced learning. Again, I'll go through this one by one. Rubas bhai, if one of you can be on unmute, that would be good, because I might be asking some questions in between, so you can respond to me. Is that okay?
Yes, Salam bhai. Okay.
So what I want you to, if I'm going too fast or too slow, just alert me so that I can slow down a little bit, or or go fast if you want me to. So there are three types of learning for the machines. One is called supervised, unsupervised, and reinforced. So what is supervised? Supervised is actually you put a label onto something and then ask the machine to learn about it. I'll explain a bit more. So here you can see 3 coins. One is a 1 rupee, a 1 euro, and 1 dirham. Okay, 1 rupee is 3 grams, 1 euro is 7 grams, and 1 dirham is 4 grams. So you let the computer know this is the property of this particular coin. Then if you have a simple weighing machine which is connected to that machine can immediately say, oh, this is a 1 rupee coin, a 7 rupee coin, a 1 rupee coin, a 1 euro coin, or a dirham. So this is called a supervised learning, and this has been used quite widely every day. Some of them we know, some of them we don't. And unsupervised is slightly different. So basically, this is there is no label data. You put loads of data into the system and ask the computer itself to make sense of it. Again, I'll give you a simple example. There are quite a few kind of chats coming in, I think. So if somebody want to look, and if there is something for me, you can basically alert me on that. So this is a cricket match. There is runs as well as wickets. Okay, on the x-axis, you got wickets, and on the y-axis you got runs. So and the data is put onto that, and you can see there are few people who has got quite a few runs, and there are quite a few people quite a few wickets. But what machine doesn't know is who is a bowler or who is a who is a batsman. And in this case, if there are loads of runs, the computer assumes he's a batsman. And if it is loads of wickets, the computer assumes it's a bowler. But this might not always be correct. And machine learning is all about probability, the best probability, or kind of, it's a kind of guessing game rather than the accurate, not like a prediction of programming. So if there is an all-rounder which might fit into all of that, both of that, the data can be slightly wrong, and that's how it is. This is called reinforced learning, which we will be going a bit more detail onto this one today. This is basically just like we are teaching a little child. So if there's a dog's coming and the child says it's a cat, we'll correct them saying actually no, it's not a cat, it's a dog. But if he says the boys or the child is saying it's a dog and it is true, then it says we'll give them a reward. And it's exactly the same way. It's working on the computer exactly the same way. You can even punish the computer saying actually it's just giving a timeout and some kind of feedback onto that it's wrong or right. Okay, hope that is clear. So now a question to you. I don't know, Dhruva, whether you made it as a quiz or not. Facebook recognizes your friend in a picture from an album of tagged photographs. What kind of learning is this? I'll give you 30 seconds. You can put it in the chat window. Ruas, is there any answer which is coming out loud?
I can see the majority is supervised at the moment.
Okay, if you have found answer as supervised, that means people were listening. That is the answer. They haven't bored yet. Artificial intelligence and Google. I have been looking through this for some time, and I'm a Google trainer as well, so I know more about Google than anything else. Google is, and to be honest, they are on the top on this game. I have looked at Microsoft as well as Amazon. They are all in the game, competing each other. But when it comes to artificial intelligence, the others are nowhere near to where Google is. Next question. Does anybody know who this is? Again, 30 seconds to answer. Namsit or Rubas, is there any answer?
Yes, someone has said founder of YouTube. And
Okay.
I hope there might be a few more answers coming, but
I think we need more response from the participants, please.
someone has just popped in founder of Zoom. Yeah. And Aegis has said it's someone who has designed Google logos.
Okay.
And by the looks of it, the ethnicity has kind of given Jack Ma.
Okay, Jack Ma. Okay, that's a good guess.
Steve Chen.
Okay, I haven't got the answer I was looking for.
Is it Bruce Lee? Is it Bruce Lee?
No, it's not Bruce Lee. He's still living. He's not dead yet. Okay, I think I'll
There's another man, Eric Juan.
no.
No.
Okay. Okay. So I'm going to give his name is actually KG. Okay. He was a champion of a game called Go. Okay. And I'll speak about, why it is important. And this guy was defeated by a Google's AI machine called DeepMind in 2017. And that news is from BBC. Google AI defeats human Go champion. And this was a huge leap in the artificial intelligence and machine learning. And Google has said this has taken 10 years away from their research, 10 years. And that's how significant that breakthrough was. And this is, and I'll tell you why that is. And this is the board game called Go. And it has got about, this is a staggering number. Look at that. the number of legal board position on a Go has been calculated to be approximately 2 multiplied by 10 to the power of 170, okay, which is vastly greater than the number of atoms known in the observable universe, okay, and which is estimated by 10 to the power of 80. And that 10 to the power of 80 is actually, that observable is quite important there, because there is universe out there which we don't know about, okay, but let's say it's 10 to the power of 80, but if you look at the number, it's 10 to the power of 170, that is 10, then 170 zeros at the end of it multiplied by 2. And it's that complex that game is. And chess, I mean, we believe actually chess is quite complex, and this is 1,000 times complex than a chess is. And another thing is actually important about this AlphaGo is it is challenge agnostic. What that means is actually, if it is they are playing Go today, tomorrow they have given chess or simply noughts and cross, it will still do exactly the same thing. And that's the beauty of it. It's going to learn about itself and speak about it. And I think as of the stones, it's called, there's about 181 black stones and 180 white stones when they were playing. Okay, this is the path of a single stone within that out of 81. And if you look at that, you can see how exponential that is. And if you draw one of that again, you can see that how that tree is growing. It can be really, really complex. And the AI, the AlphaGo was able to defeat that person in that game. And he was an unbeaten person until that time. Okay, I'm gonna have some fun with AI ML now, because you have been listening to me for some time. So I'm gonna share my iPad. Can you see my iPad on the screen?
Yeah, we can.
Okay, cool. Okay, this is something called autodraw.com. You can go and have a look. Why I took iPad is because it's a bit more easier to draw on it. So this, you can draw, let us say I'm gonna draw a car. Oh, it's not a car yet. Oh, okay, let me just undo that. Start over. That's not a good car, is it? I don't know, because it's sharing. It's quite slow. But anyway, okay, because, okay, let me just draw something else. Okay, so look at that. So it basically since I was sharing the screen, it was quite slow, but normally it's a bit more faster. So from the drawing which I was doing there, it is kind of guessing what I'm drawing, and it kind of creates an image based on it. And this is purely AI so let us draw something else. What do you want to draw? Okay, let us see whether I can draw a leaf. Is that a leaf? I don't know.
Try a mobile, Salam.
Okay, so you can see when I draw that much, you can see on the top, it's kind of auto draw. Do you mean, can you see that on the top? Do you mean leaf? And it is showing different kind of leaves in there. So see, I can select that, or I can say select one of those, or it can be a feather. So it kind of guessing what I'm drawing. So what's happening is actually from the move, it kind of guesses, because it has got loads of data of the people who has drawn before and loads of images it can scan through and kind of guesses what it is. And there is a similar game called Quick Draw, and this is a game which you can play with your family. it's quite nice. You can see I will get 20 seconds. Within that, I had to draw a nose. Okay, I'm gonna take that challenge and see whether I can draw a. Oh, it guessed it. Okay, okay. That's I was playing last night, so let's draw another bench. Okay, and I'll get only 20 seconds. Come on. Okay, bench. So how do I draw a bench? Is that a bench? Hey, yeah, I got it. Penguin. Yeah, I got it. So this is the idea. So in this one, what's happening is, you know, if you look at the bottom, it kind of guesses all the time what, I mean, I don't know what it was next. What was it saying to draw? I don't know.
Tree.
Tree, okay. Oh, donut, next one. Okay, you can see in the bottom, it will try. So you can see it's a circle, and it's immediately trying to guess what it is. Yeah, so I'm getting it right. So you got the idea. So basically, these both games are from their, you know, just their trials on artificial intelligence. So in this one, what's happening is, you know, from the drawing, it kind of guesses what we are trying to draw, and takes from there, it makes some prediction based on that. And I'm gonna, you know, give you, you know, what it is trying, how it is working out, what, you know, what we are, how it is working it out in next, you know, few slides. Okay, are you back to the screen? Yeah.
Yeah, we are.
Back to my screen? No. Is that right? Which screen are you seeing?
Yeah, your screen,
Yeah.
your drawing screen.
Okay, cool. Okay, so this is auto draw, which is what I was showing, and this is the quick draw, which we have already seen. And there is another one called Google Cloud Vision API, and these are both are working based on the same technology used by Cloud Vision. Cloud Vision, it might be something we always use. If you are using Google Photos, you can see something called Google Lens in there, and this is their, you know, as you can see, it's Google Vision, and this is a good example of. So I'm uploading a picture which I taken from Istanbul a few years ago, a family photo, and I'm just dropping it there. And obviously, I'm not a robot, although I sounds like one. And it kind of works out. So look at that. It kind of says it's called Galata Tower, which is in Istanbul, and you can see it even locates where it is. Within, and how long it took less than a second to work out where it is. And even see, it even finds out the faces, and this is, you know, the scary stuff. It even find out the kind of you know, the expression you got on your face. So you got, you know, my son, my wife, and my daughter in there, and you can see, you know, look at their face too, which is my wife, which is obviously very happy because she is not spending the money. I was. And you can see my daughter as well, you know, she's also extremely happy. And my son is kind of neutral, and obviously, you know, people who knows me can, you know, find out, who know why that is. And this is how it is, where the technology is going. And if you look at the, you know, the objects in there, it kind of says there are people in there, and there are some labels. There's a landmark, a tower, tourism. So all this information, a wealth of information, what they have done is just from the photo I uploaded. And there is something, obviously there is something called Google Lens, yeah. And this is a video I taken from my phone. And let me just play that. So basically, this is so if you look, this is a picture of Acropolis in Athens. On the back, it's one of the monuments in Athens, and that is again me there. And if you look at that, if you look at put on Google Lens, it kind of scans it, as you can see some dots coming on that. At the end, it says predicts exactly what it is and where it is. And it gives all the information based on just that photograph. So what it says, look at this, scans that photograph and look at from its, what it has got already, the wealth of data Google has got, and just matches the width and the height and all of that within few milliseconds, and just comes back and says, okay, this is what it is. And it even gives the phone number of that location. So if you have a photograph and you want to call them, you don't even know what their office is. There's even a phone number in there, so by which you can contact them. So this is, very, very powerful. So let me just go back to, so these are some of the things in practice, what is happening. Hanin, by the way, do you know what happened to the delivery? I'm already hungry. Hanin?
Yeah, I think the store is quite busy, so I think they're just packing our order now.
Okay, cool.
I'll let you know when it leaves the shop. Okay,
please. Thank you, Hani. Yep. So I'm gonna go a bit deeper now, and just to explain how that things were happening. So far it was kind of practical. I'm gonna go a little bit theory. So what is artificial intelligence? And I'm not gonna read through all of that. So if you look at that, there are 3 circles in there. Underneath, it's deep learning, machine learning, and artificial intelligence. So machine learning it's all of that was a starting. So what we have these days is actually data, millions and millions of data coming in every second. So what's happened in last 10-15 years is the cost for the storage has come right down, and the machine has gone really, really fast. So every time we go to Facebook or search, the data has been created and they are being stored. Even if you are searching something stupid, and that's all being stored in a database by Google. And there was an influencer study that done in about 2017, just to predict where the influencer, that was in the UK, where the influencer will come in, and whether it's H1N1. So whenever you have a headache or something like that, you're going to search, about the, I have a cough or something like that, where the next pharmacy, and they're going to store that. Based on that, they kind of make models out of that. So that's what the machine learning is. This is, going through the wealth of data and making sense out of that. So I'll give you an example. In my office, we get the data from Facebook, Twitter, and, and YouTube, and all the things which I don't really know about, all the teenagers and all use. And I'm not a great user of Facebook, but yeah. So they get all that. They do something called what is it called? Their analysis on the behavior of the user. So the CTO going to ask, or a CXO going to ask, how did we do last year? So they get all these data, including the call. When you sentiment analysis, that's what it is called. So when you call them, they store the audio data, and there is something called Amazon Poly, which converts that audio data into text, and they can go through that text. So even if you're calling, they can go through that text and say, okay, last year the customer was not happy, and you're going to ask why that is, and they might say, okay, this system was running a bit slow, or our main website was down for a few hours. Because of that, the customer satisfaction has come down. So that's what this machine learning is. Deep learning is actually, from that model itself. So you have done halfway through. So from the result of that, they make it individual balls of individual news. From that, you can infer it. You can, infer much, which more relevant data out of that. That's a study of the results itself, which is what, CR probably can explain it a bit later in the next talk. So that's what called deep learning. So it's you know, if you look at it's a subset of machine learning which tasks are broken down and distributed into machine learning algorithms. So that is called models. So it's study about the models itself. Artificial intelligence is just a covering out of all this, which makes use of deep learning and machine learning, and makes practical things, you know, helping the prosthetic limb and things like that. That's what artificial intelligence is. It just, you know, basically the usage of machine learning and deep learning. And this is what I was talking about, the you know, deep learning. So if you can see, this is what the machine learning creates a model out of that, which is what you can see, this hidden out of that. And you know, from that, you're gonna get a set of output, which is what, you know, as I said, when the CEO calls and says, you know, how was the customer feeling in general last year, and you know, they said it wasn't quite good. Then there is people called you know, data scientists, and that is people like you know, there is someone called CIGI in this call, and they go through that data and find out exactly on what time, on what, you know, what day these people were upset and about what. And that's what, you know, and if you look at that, you can see some lines across. That's called neural network. And that's called, as I said, you know, it's because it's a bit cool. There is nothing to do with our, you know, our brain or anything in there. It just, you know, some funky word. And this is a simple example of a machine learning and a deep learning. You got an input and you got a feature extraction, which is what I was talking about, you know, the labels, and you know, then based on that you get a classification and you get an output saying whether it is a car or not a car. So in feature extraction, you can say, you know, it's got 4 tires, it has got a, you know, 4 windows, or you know, 6 windows if you say, you know, take the front and the back. That's what the feature extraction is, and based upon that you can classify it whether it's a car or not a car. Whereas deep learning, it's kind of going back and forth, so it comes back to the feature extraction again and say whether it can be. So if there is a sports car and, you know, a top open top car and thing, you know, it's be quite difficult for a machine to understand whether that is a car or not. And if you look at the cars, the variety of cars we have these days, it's quite very, very different. So it's not just one car it has to understand any car. And even some cars, you know, it can be kind of trucky car with a bit of, you know, space on the back where you can, you know, carry things, which is mostly used in America. So that can be considered as a car or a truck. So those you know, if you put it in this machine learning, you know, algorithm, it might not say whether it is a car, but if you put it in the deep learning algorithm, it will definitely say it is a car or a van or a truck in another case. So this is something called a linear regression. Linear regression is something we were traditionally using this as an example here. So you got a small house, which is 70,000 pounds, and you got a bigger house, 120,000. And if it is a bit more bigger, it is about 160,000 pounds. So, and this is all a linear curve. So you're just assuming as it goes bigger, you know, the price gonna increase. And that's probably not the case. For example, this house, if this house is in a flood-prone area, the price is going to come down. And if you take that kind of approach onto our normal life, this is what's going to happen. If you look at that, as you can see, so this is the first day of wedding. First day of wedding, you obviously have, you know, one husband, and if you plot it across for, you know, 10 months, it says. You know, by end of next month, yes, you can see the end of next month, you will have over 4 dozens of husbands. And this is where it gets wrong. There's an obvious mistake in there because the sample data is quite low. They have taken only one set of data, which is normally the case, which is not normally the case, but for the sake of it, for a laugh, it's quite nice. And this is called a scattered graph. Again, you know, in next class, hopefully, you know, CR will be going a bit more detail on that. So this is considering other facts. This is you know, the kids passed or failed in in a test. In this case, it's just passed and failed. It just draws one line across, which kind of classifies average students and above average students in there. But if you look at it, it can be more complex than that, and rather than a linear. So this is taking care of multiple dimensions. For example, in modern kind of data extraction, people take multiple items. So in the same kind of same example of the house, there can be the location of the house, the price can be different. So this is kind of taking different elements and adding multiple dimensions to that. So I'm not going too detailed in that. So what I'm saying is actually it's not always linear, and in a machine learning algorithm, that's exactly what's happening. Basically, it takes multiple properties of a particular data in different direction and slice and dice it as it requires. So let me see, how does it work? How this kind of machine learning works. So I'm going to give you a quick question in here. I hope you haven't slept yet. Yeah, I hope you are all with me now. So in this one, my question is, which one are the shoes? Rubas? Or anybody who's muted, not muted? Hanin, can you tell me which are the shoes?
Bottom left, and then the third one on the second row.
Okay, and that is correct. And it's quite easy for us to understand which which one is which are the shoes. But for a computer, it's very, very difficult to understand which is which one is a shoe, because we kind of infer whether that's a shoe or not, because we have been seeing shoes for probably from year one onwards. If you look at this one, the shoe, the first one and the third one is very, very different. And if you said in the first case we were saying the labeled data supervised learning. So if you say the shoe look like this with a flat bottom and lace and two colors, it will only recognize that as a shoe, whereas it wouldn't recognize these stilettos as a shoe. That is just because our brain is so powerful. It can go back to our 20 years of data within milliseconds and find out exactly what it is. But unfortunately, the machine can't do it. We had to teach them which one is a shoe or not. This is another question. So I'm going a little and one notch up here. Then this part is actually quite important. If you understand this one, you know exactly what a machine learning is. Okay, so could you just tell me what the pattern here, what is the relation between X and Y here? Azim is a doctor, so I'm pretty sure he would know. Can you tell me the relation here?
We are seeing few responses on the chat window. Do you want me to read that out?
Yes, please. Yeah, at least one.
So Mohammed Sinad says X differs in 1, Y differs in 2. Is that the one?
Y differs in 2. Yeah. Any other ones?
We have few more. Ajaz Samad says X equals 1, Y equals 2.
Okay. Okay. Yeah, 2x is not correct. It's 2x minus 1. So if you look at the pattern, it's minus 1 minus minus 3. That is 2 multiplied by minus 1 minus and minus 1 out of that. So minus 2 minus 1, that's minus 3. 2 multiplied by 0 minus 1. Okay, and 1 multiplied by 2, it is 2. 2 minus 1, 1. Okay, so what will happen in our human brain when we are working out this is we're gonna go on first one. Oh, minus 1. Okay, let me just take a pointer and it might. So in this one, it's quite clear. In the first one, we're going to work out what is it? It's multiplied. Yeah, it is kind of 2x minus 1. So by the third one, you know what the answer would be. You would say it is 2x minus 1. From that time onwards, what you're going to do is fit this answer to the rest of the things. You're never going to go until the end of the pattern. And that is very, very important in the case of machine learning. Okay, so what machine learning does is exactly what our brain does from half the time onwards. So by this time, you're going to work out what the formula is. From there onwards, you're going to fit that answer into the question. Okay, so you're flipping it around. And that's what a machine learning does. So I'm going to give you a bit more detail onto that. So in traditional programming, if you know, what happens is, people who are, somebody raised the hand. Okay, you can put the question in the question window if you want. So you got the rules and the data, and you got an answer. So let us say, I want to see all the employees who is less than 40 years old. And so what you're going to do is actually you're going to go through a loop saying, go through all the employees within that company. Let us say, for each employees in employees table, and if the age is less than 40, you get the data. Okay, you get an answer for that. But in machine learning, if you understood this, you're going to say, oh, is that it? What a machine learning is, what an artificial intelligence, and it's quite simple. So what happens in machine learning scenario is you put the answers in and the data. Okay, and in machine learning, guys, where you got the model in there, what you spoke about there, and you got the rules based on that. So this is basically exactly what you were doing from here onwards. So you got the answer already, and you try to get, and you got the data as well, and you try to fit that questions into that answers. Okay, so you already has to feed the answers to the machine, then only the machine learning will work. So this is just like asking me to fight with Mike Tyson and say win it. Yeah, so I know what is the outcome, to win the boxing, but I'm not as strong as Mike Tyson. Obviously not. I'm sure actually his small finger would be enough. But I don't have a choice there. The only choice I have is to fight, because I know the answer is given to me. The end result is given to me. So this is again asking me to with a tennis racket and say your task is to win, but you had to play with Rafael Nadal, for example, or or people on the top. So at that time, again, you had to learn it quickly as possible. That's exactly a machine learning does. Hope that makes sense. Okay. Now I'm going to give you, I'll give you an example of what I meant by that. Okay. This is a game called Atari Atari. Okay. And this is one of the old games we used to play it in the lab. When this was the only game you can get on a Unix machine. So the idea is actually you got this a blue line there, and there's a little ball. It's gonna bounce up and down. Then you will be moving this blue line left and right to block that ball, and don't allow it to go downwards, and break all the all the bricks here one by one. So it kind of bounce up and down and break all of these bricks. That is the idea. So what happens is, when in a machine learning algorithm, there will be some score here. So what is given to the machine is, as I said, increase the point here, and the clue given to that is just these pictures. Just it doesn't even know, the machine doesn't even know this moves. As I said, this is just like giving me a racket and putting me into a tennis court and say you win it. I know the answer, but and then I know who is coming on the other side is Rafael Nadal, for example. Okay, and at that time again, and I don't have a choice but to win it. So I'm going to give you, I'm going to show you that and again, watch this quite carefully. Okay, and oh, not that one. I was queuing something yesterday, that's why. No. Sorry. I don't know why that is not finishing. Oh, that is sorry. The deep minds, this one. Oh, I clicked on the wrong one.
Dad, should we check up on our food?
Yes, please. Yeah.
So let's just have a look at the app.
Do you want to share this? Share the screen?
I have done, yeah. So
Okay.
we can see here that our robot has been packed and it's on its way. So that's
Okay.
And that's our house on the right. So you can see about halfway here.
Okay. So do you want to share the screen and show it to everyone?
I am showing the screen.
Do you have to stop sharing, Salam?
No. If you it starts, it will automatically go away anyway.
It's not. Yeah. Do you want to start sharing? Yeah, it's come now. Yeah, good.
Okay. Okay.
So what's happened is actually, so you can see a little robot there on the screen. So that robot is, my biscuit. It's kind of loaded onto that. It's kind of started from the supermarket, and it is on its way. So it's arriving in 23 minutes, but now it's gonna update, every other minute and let me know where it is. Yeah, but that 23 minutes seems to be good. I just started, honey. Is that right?
Yeah.
Okay, cool. Yeah, you can stop now. Thank you, honey.
That's all right.
Okay, I'm gonna share back my screen. Sorry. So just back onto my Atari Breakout. So Atari Breakout, as I said, it's an old game. It was even available on a text only machine, like a Linux machine. And you may want to read this. The most important things to know is that the agent is given the sensory input, what you see on the screen, and it was ordered to maximize the score on the screen, and that's it. Okay, so it is just given the screen and said, can you see the screen, the point on the top, just to maximize it. And no domain knowledge is involved in this, which means the algorithm doesn't know the concept of ball or what the controls exactly do. So it just asked, to play, just given the tennis racket and say, yeah, go and play. And then let us see what happens. So this is starting in 10 minutes of training, okay? So you can see that the red line is moving left and right, and you can see some balls escaping. So the ball should not be, so in a proper game, if you are really good, the ball should not be going beyond that kind of reddish line. But you can see he's losing quite a few times. This is after 2 hours of training. This is, the machine is asked to keep on playing the same thing, and it kind of works out from its mistakes. So this is where we were talking about the reinforced learning. So when the ball goes down, it gets a punishment. This one goes down. The kind of pawn goes down. So it knows that I have done something wrong, and it learns from that and keeps on playing. I mean, if you can understand this well, I think, I have done some justice to my class today. So this is after 240 minutes, which is after 4 hours. This is where the magic happens. It realizes that digging a tunnel through the wall is the most effective technique to beat the game. Okay, and now let's watch that. So it kind of, if you look at on the left, it kind of creates a tunnel there. And the good thing is the machine itself has worked it out, yeah? So this is probably, in Nadal's case, I'm finding some way to cheat Nadal. Probably I'm going to go back and cut his strings or something like that to win the game. So it kind of works out itself to how to get that higher score. And that's quite amazing. And this is actually, it was a surprise for the people who developed this as well. So they might not have been able to play as good as the machine itself. So this is what we call the reinforced learning, and the deep learning comes in. When the second part of that is where the deep learning comes in, it kind of thinks, it got a model first. So the idea is, to break these breaks and get on the top, but then it worked on that model itself and found a better way to do it. Okay, it's kind of better itself. Hope that is made some sense. So let me go back. And that game is called Atari Breakout, and this is exactly the same thing which they developed as AlphaGo, which defeated the champion. And it's exactly the same algorithm, if you like. Okay, so I'm going to go a notch up here just to for those who has studying for postgraduates and postgraduates and who has done engineering and stuff like that. But I'm pretty sure others will also understand. So there's a game called rock, paper, scissors. So I'm sure some people might know. So basically, if you hold your hand like that, it's a rock, and this is scissors, and this is paper. Okay, you might be thinking, wait, this is about an artificial intelligence. Why this game? And this is important. So the idea is actually let the machine understand what your gesture is. So if you put your hand like that, it is a rock, and if you put your hand like that, it is it's a scissor, and if you put your hands like that, it's a scissors. And it's a game kids here play, like we were used to play it at home, something like what is it to defeat something, the akkara gukkara puchapi and game, and something like that. I can't quite remember that. It's similar to that. So when it comes, two people put the same kind of gesture, that's a draw. And if it is a rock and a paper, a rock gets the priority and things like that. So this is just to make the machine play that. The problem with this, I mean, if you're doing the traditional programming, that we had to program for all these different kind of hands and different kind of gestures as well. And also, some people can say a rock like that with their thumb out, and if it is paper, some people can just do like that, and some people might be just with 4 fingers. And if you look at these different skin tones, there is white, black. So to work out in a traditional programming, you had to write hundreds of thousands of lines of code. And even then, this is pixels. So every pixel, for example, if it's a black pixel, black hand, there'll be loads of zeros in there just under to make out. It can be really, really complex. We had to cater for all these scenarios. But if you just go back to the machine learning, we already said we will feed the answer to that. So the answer is this. You have 3 possibilities. One is rock, another one is scissors, and another one is paper. There are only 3 possibilities you can have. So the machine already knows the answer. That is the learning phase. Okay, at that time they're going to create a model which is there, which is where your neural network and everything comes in. Then you don't need the answer from there onwards. You only need the predictions. Okay, so I got the game, the code for the game with me, and I'm going to start it because it's going to take a little bit of time to run it. Okay, so this is the code, there are a few things before that to load the images and things like that. There is about 840 images being loaded of each gesture. So you got total training images, rock is 114 and paper is 814 and scissors 814, okay? And it has, they are all by 150 by 150, quite small images, and about, three bits of color. And then it is just asked to make a model and get it right. So let me just run that. Okay. So it just started running. So if you look at the bottom of this one, it's gonna give you an answer immediately. And the accuracy, if you look at the accuracy, 0.4, and that's pretty 0.35, which means it is pretty much, it hasn't learned anything at all, because what it is saying is it can be rock, or it just divided by 33%, which is exactly 1 by 3, which means actually it could be rock, it could be scissors, or it could be it could be paper. It just says one of those things. But this is just first iteration of that, and we will come back to this after. And each of the iteration have about 79 functions within that, just to learn about it. And this is the important bit. If you look at the accuracy, it is 33%, yeah, at this point. And we'll come back to this one and see after some time what happens. My machine gonna go a little bit slow from now onwards, I guess, but I think it should be all right. So now, from now onwards, what is happening in that game is this inference phase, not interference actually. So you got the data and the model, and it's going to give you the predictions, which is what we want. And what are the predictions you have? There are only 3 predictions you can have: either a rock, a scissor, or a paper. Okay, and this, which is what it was giving out, and it had only about 33% of accuracy. And how does it check it? Because we know what the answer is. So it just check with the real answer and say, oh, it's wrong, and it's going to go back and iterate the same thing. So you can see this is the code for that. You can see it's a 150 by 150 and 3-bit color deep. You can see, and there is a 512 there, and I'll just explain what that 512 is. So you got the function from 0 to 512, and if you have a hand like that, and these are the pixels within that hand, and just inverts that that particular picture and puts it into that 3 categories. So you can see 1, 0, 0 here. So 1 is rock, and 0 is these are rock, paper, or scissors. And the first this function, by looking at this hand, this function is saying it is a 0. It is a rock. So which is why it has put 1. And what happens is it initializes different variables within that. In machine learning's case, it is called parameters, but it's not parameters. It just self-initiated variables to fit into that, because we know the answer. As I said, that's quite important. We know the answer. Okay, and that 512 is basically going through that same function 512 times, but with different variables. Okay, and in the second one, you can see it's a different hand there, which is like that, and it says it's a paper. So you can see all the functions are saying it is a paper, and it's kind of iterate the same thing for 512 times. And you can see a little fungus coming onto that, and as I said, that is called neural networks. And this is nothing but the same function trying that function with the different variables to get that answer, that particular answer. So because of the iterations, you can see it's kind of going and coming back like that. So it will gonna create something like a web. And to make it a bit more cool and a bit more current and a bit more mysterious, they calls it a neural network. It's nothing to do with our neuron. It's quite simple, as I said. It's just initializing those functions with different variables, random variables to fit into that category. Hope that makes some sense. Okay, and there is something called convolutions, which is also happening. Can I have the time, please? Rubas, am I on time? Namsit? Am I good with time?
Yes. Do you have more slides
No, not much.
in the deck?
No. Okay, how much I got?
I think you can try and wrap it up in 5-10 minutes.
Okay, that's fine. Thank you. So there is something called convolution happening, and the convolution is nothing but if you have worked with photographs, it's just filtering. So in this case, you got few stairs in there, and it takes it puts some lines across it and makes it quite small. What happening in that one is some of the characteristics of this stair will become quite clear in here. You can see it, the machine will be able to understand its stairs. So basically what's happening is it takes the clear ones on the top, and which is what basically in this one they are taking 1, 2, and 1 here. So if you look at, in simple terms, if you put some filters in there which makes some of the properties of that picture very clear, and that's called a convolution. And there is something called pooling as well. So pooling is basically compressing it. So in this case it takes you got a pixel there, about 4 pixel in that one. The highest number is 192. It takes from there. So it takes what is very important. In this one, you might have seen, like in music terms, this is just taking some of the noises from that music. So if you take some of the, if you are into music, you can see there are some when they are recording, there are some things you can goes up and down. That is making some of the music, some of the notes in there very clear. And this is exactly the same thing happening, but in pictures. And pooling is just compressing it. Just like in music's case also, you can have MP3s, which is quite new. And before that, there was WMA and those kind of things, which was quite heavy. So what's happening here is, it takes the important property of a pixel and makes it small. Because this is machine learning, you want to make it as fast as possible. If you have a bigger picture, it's going to become very, very difficult for the machine to work on it. And these two things are basically making that image manageable by a small machine, or a big machine if the data is more. In this case, actually, this was the simplest game I can get to make to explain about it. And this is a pooling example, and you can see once it is pooled, this is actually 1/50th size of this one, on what you see on the right. But if you look at that, it hasn't lost much.
Dad.
Yeah.
Our delivery is almost here.
All right. Okay. In front of our house.
Yeah.
Okay. Brilliant. Thank you very much, honey. So can you put on to your screen, please?
Yeah.
So we're gonna get that our delivery. Is that okay? Yeah. Yeah. Honey, you are on the screen, I think. Your screen is being shared.
My screen is being shared, yeah.
Can you zoom it?
Yes.
Speak about it. You can see it's coming.
Yeah, so
basically now what's happening now, that is my biscuit coming in, but because there's a car in that driveway coming.
Salam bhai, I think we seem to have lost you.
Yeah, I think when they go out, probably the Wi-Fi signal has lost.
Yeah, it has come back. It has come back.
okay. Shall I?
No, I can't see actually. Rubas, can you see the screen? I am seeing a frozen screen.
Yeah, I am also seeing a frozen screen, but I think for an understanding, you can see that there is a robot on the right of that van. I hope once Salam bhai joins, yeah, he's there now. Perhaps some social distancing from Salam bhai?
Could possibly be, or just a loss of signal. But I think what we saw there was an AI-driven robot that made its way to Salam bhai's residence with the items that he had ordered. I guess that was what we're going to witness.
You're not sharing.
There you
go.
Can't you see the screen?
Yes, now we can. Now we can.
Now you can. Okay. So now we just need to go to the app and open it up.
I don't know why it is not coming to the house yet. It's I think we got a naughty one today. It's not good.
Salam bhai, COVID measures.
Yeah, I don't know what it is. I think it got a punctured tire. I don't know. Shall we pick it up now?
Yeah. So I'm just
share the screen.
Gonna switch to the app.
Salam bhai, just for everyone's benefit, can you please tell us what's the distance it has traveled?
It has traveled probably about 2 miles.
Can everyone see my screen now?
We can.
Yeah. Go on.
Yep, so I'm just going to say that I'm next to the robot and then click the unlock button and then quickly switch back. And you can see.
Here's your delivery.
It's just.
You hear that?
Oh, no. Hang on. There you go.
So, yeah. So you can
And then once you've closed it, you go back to the app.
And that's my digestive.
Wait. Once we're back on the app, we can just send the robot away. Ooh.
Thank you.
Sorry?
Hang on. There we go. And once it's shut and I've told it to go away, it will drive off in a minute. Off it goes. It's back to the supermarket now.
Yeah. So you can see my biscuit in my digestive biscuits, which I was ordering. Can you see me now?
Yeah, we can.
You might have to move away. Sorry. So here is my biscuit, which I've ordered, and that was complete. That that machine. Can you hear me now?
Yeah, we can. We can.
Loud and clear.
So yeah, so that is a typical example of what AI can do, and that's been used, heavily here, especially during. I mean, it used to be about 15 to 20 minutes for us to deliver it because of the COVID. I think pretty much everybody's using it these days because they don't want to go to the supermarket, and this is a perfect way of ordering things and getting in few minutes without going to anybody or touching anything. So yeah, pooling example. So basically pooling it was just to go back, it's just a compression idea. And now let me just go back to the program it was running. So we got about 33% in the accuracy in the beginning. Now you can see it's about 82% accuracy. So, and it's only done 4 iterations on that model. So we started with just 34%. You can see its accuracy. So if I put what it is saying, 82%, it means if I put upload a picture or just show like that in front of a camera, it is very likely to say it's a rock. There's an 82% chance it's to say a rock. Whereas if I put like that, it will say a paper, and again, there's about 86% you're going to get it right. So let us see, by it is doing, this is 4th iteration, it's a 5th iteration. So if we do, and there are 25 iterations, they can, I have programmed it to go. So by 25, I'm pretty sure it will be more than 90%. So you can see it is 86% now, 93%. So, it kind of keeps on increasing. I hope you got the idea behind it. So if it is not clear, please, I can go back and explain a little bit more. Is that at least you got an idea about it? Namsit? Yeah? Or?
Sorry, just coming out of mute. Yes, that was really clear, and I think the concepts came out really well.
Okay, cool. So, so in this one, I have used, in that programming is basically something called TensorFlow. It's an open source from Google, and the programming language is called Python, and TensorFlow has loads of pre-trained algorithms you can get. So if you want to create something out of that, there are hundreds of people who has as a community has created pre-trained algorithms in there about hearing, like something like Alexa or Google Home. You can get those kind of pre-trained algorithms in there, and you can build up on the top of that with whatever you want to do. And as I have shown, there was 840 images uploaded onto that, and you have put convolution there, which is basically in simple terms applying filters, and you apply pooling on that, which is basically just compressing that that picture without losing much of the information there, basically removing the noise out of that picture. And you can see something called do something called PyCharm. Instead of that, that tool I was using, this is basically called this one is called a Jupyter Notebook. So if you go search for Jupyter Notebook, you can get something similar, and you can write your own code in there. And this is something called Colab, and you can.
Salam, are you sharing a screen with Jupyter Notebook or just a presentation?
No, I was sharing. Oh, okay. So
yeah, you're not sharing. Yeah, okay.
Okay. No, I was sharing that. So I think
we can't see that. Yeah.
You can't. Okay. What I'll do is I'll stop share. I think I was sharing the slide rather than the screen. So I'll share the screen. Okay. So you have, when I say 85%, you haven't seen my screen?
No. No, I think.
Oh, sorry. I was showing the screen there. Okay, so let me just go back. Sorry about that. Because I was sharing the window. So can you see my program screen now? Can you see my?
Yeah, yes, we can.
Yeah.
Okay, so you can see we have started with the 34% accuracy on that, and now we can see 90%. What that means is, if I show a rock in front of the camera, or if I upload a picture of a rock, it's gonna say it's a rock. If I hold my hands like that, there's a 93% chance it's gonna get it right. That's what it is saying. And if you look at that, it's kind of learning by itself. So I haven't touched anything after that. I just put that code in there and asked you to learn about it. This is exactly the same concept as I said. You are put in front of there's a girl in India, isn't it, Bindu? Is that right? Who's the badminton champion? And you are asked to play with her and win. And you know what your destination is, what the outcome is, and you have given the tool as well. From there, there is no choice. You just have to learn and learn and learn, and beat Bindu, I think. Is that right? Bindu P, I think. The badminton.
Sorry, it is Sindhu.
Sindhu, yeah. Okay, but now let me just calm down a little bit, because I know it was probably a little bit too much. Is it relevant? Why should I bother about it? I mean, you have seen in action, which is why I wanted you to see. So I have ordered something and I haven't moved much. It was in front of my house. It was delivered just over there. And, it's used in healthcare, which, I'm pretty sure there will be people talking about it. There is fraud detection. And this is quite important in our case, whereas, when I in my work, this been used up to a level. So basically, if there is it's not kind of what's happening in traditional ways is if there is an IT system, if it is attacked, it's kind of reactive. Nowadays, it's not reactive. It's kind of look at where the hit is coming from. If it is from North Korea, there is a good chance it will be monitored all the way through and see, or if it is 2 o'clock in the morning from a university about 5 people coming in. There will be something called suspicious transaction is coming in, so that transaction will be all monitored all the way through. And if there is something happening, so there will be an extra pair of eyes on that. These are all happening today, and the more it's getting more and more sophisticated, and everybody is about worried about the fraud and the security of their systems. And there is sentiment analysis, which I was speaking earlier about, the thumbs up and thumbs down and those kind of things, which I don't really get my head around in Facebook. I have spoken to Facebook, but I'm not a fan of Facebook. Military, there is another area which is which, as I said, unfortunately going in a real fast. And the e-commerce actually, if you remember the story I started with about the baby item, and it's already happening every day. And this will be touching every aspect of our life, whether we like it or not. In one day, or if it not already is, it is. I mean, if I say from here now and say, Alexa, light on. Can you see? Alexa, light off.
We cannot see the light, Salam. We are seeing. Are you sharing the? Are you sharing the camera?
On his spotlight.
Yeah, spotlight. Can you have Alexa, light on? Okay. Alexa, light off. Okay. Did you see it?
Yeah, that's visible. Yeah.
Yeah. So that's what I was saying. Every aspect of life, we will be this will be touched, and that thing which I spoke, that Alexa, which was only about 30 pounds, so it's kind of coming. The price has coming down as well every time. And obviously, my little friend, you just have seen, we call him in my house, we call it the boy. He's kind of really, really cute. I have seen people passing. This is the house this is the road in front of my house. And I have seen when people going past, they stop the car and take a picture of it because it's kind of cute as well. And one thing I have noticed is actually when my brother's son came, he stood in front of that machine for about few seconds, and he said, "Please." Move what is it? Yeah, please move in from front of me because I have too many things to deliver today. And that thing, nobody's talking, nobody's asking him to to say that. What's happening is it kind of works out. It's a little boy and he doesn't want to be rude, and it says actually something like, I think my friend, could you please move from front of me? I got a lot of things to deliver. So there are but tons of cameras around it, kind of works out it way. It knows my address and it put all the things from, and if you look at the shop in there, you can see it's queuing up in front of the shop, and it's really nice. It's quite, kind of cute, I would say. And yeah, this is one aspect of what's happening, in this field. I hope you liked that delivery thing and the biscuit story. And so what is next? The simple answer is I don't really know because this can go exponential. But what I can say for sure is actually this is to stay. This the robotics and the machine learning and the AI will only grow in next few years. And what is it gonna disrupt? Can somebody tell me what this is? Just one. Even the moderators, you can shout and say.
Chandelier.
That's IBM supercomputer.
Ah, okay. Close. Somebody said it's a chandelier. It's not a chandelier. It looks like a chandelier in a masjid or something. It's not.
A new deep learning sort of device or something.
It's something called, it's not from IBM, it's from Google. It's a quantum computer.
Yeah, I think Mr. Zakir Riaz just pointed to that. It's a quantum computer.
Yeah, you got it. Zakir Riaz got it.
Well done, Zakir. Yeah.
Okay, well done, okay. It's a quantum computer. So basically, this is just like we created the first computer. I mean, it was about as big as this room when it was originally created. And this will become smaller. And this, if it comes in, it's going to disrupt everything. It means actually it will be a game changer. And what I would like to say about this one, it's not a natural progression from a computer, a normal computer, to a much more powerful computer. What's happening now is there is something called parallelism happening. We always say, there is multi-threaded programming. So basically you ask one thread to do something, and after some time you're going to catch that thread and say, there is something called map reduce, which is used in basically in data mining. So what's happening is there will be load of data.
Can I briefly interrupt you? I think can we wind up in 5 minutes?
Yeah. This is the last one. This is the last one.
Thank you.
So so in parallelism, although we say, we are running the programming in parallel, it's not actually happening in parallel. What's happening is it's just multiple cores. You just split that job into multiple streams and kind of join it together and take at the end. What this does is actually real parallelism. So just to give you an example, you have 8 cards, put across the table, face down, and you are asked to pick up, joker from that. What in traditional programming happens is actually you flip one and look at that. If it is not joker, you put it back, you take the next one and go by, and that's called sequential programming, okay? And that's what is happening today. But once this is coming in, what happens is actually it's going to flip that 8 of them at the same time and flip it back at the same time. So it can be in 2 positions at the same time. It can be a 0 and a 1 and anything in between. It's something called qubits, and it's a very difficult concept to understand. So if you understood quantum physics, then you will understand what a quantum machine is. And if this comes in, all the security we have, which we call it TLS, which is transport layer security, they all will be disrupted. I mean, if you try to break into a TLS now with the current technology, it can take probably up to 20 years to get it with a random hit. But if you have one of these, it will only take seconds to break into that. So it's a scary thought, but but by that time, hopefully everything will change with that. So just to kind of compare this one, if you take a candle and a light bulb, this is that kind of a progression. So light bulb is not both gives the light, but it's not a natural, light bulb is not a natural progression from a candle. And this is similar to that. So, the quantum computer is not a natural, progression from a normal computer to a quantum computer. So these are some of the resources I have used, and and obviously you can use Google and find out a bit more in there. And I'm going to stop with this one. This is Ronald Rumsfeld. I don't quite like the guy because he was part of the in Bush administration in America, and he was quite instrumental in the Iraq war. But I like his quote. This is one of his quotes. He says, somebody's kind of putting his hand over that, so I can't read. There are something called known. These are the things we know, and we know that we know about it. This is just like I'm speaking to you, the glass of water, and we know there is a glass of water. So it's known. And there are something called known unknown. That is to say, there are things we know, but at least we know we don't know. That is about the universe, for example. We know there is the universe is vast and big, but we don't really know much about it. But at least we know we don't know about it. But there is the next thing. There are things which are known as unknown unknowns. This is pretty bad. There are things we don't know, and at least we don't even know we don't know about it. and that is probably the area, or this I will come and show. Okay, there is nothing called the unknown. At least we know about it is unknown. With that, I'm stopping. Thank you very much for your time, and I hope it made some sense out of this. So what I was saying, as it said in the beginning, I don't think I can change everybody's perspective within an hour. But if I say, one person, if I can inspire one person out of this, 1 hour, I think I will be pleased by that. With that, I'm stopping. Thank you very much for your time, and I'm happy to take any questions.
Yeah, Salam, that was absolutely wonderful, and I'm sure everybody will agree. That was really, thought-provoking, interactive, interesting, with a live show. And I think most of the audience have already picked up that most of your life is built around AI. They've picked up your Alexa, they've seen your Tesla in the background, and they already picked up on that, and they also saw the robotics and also your whole passion about automation. So great. That was super informative. I think we can go on to the next session of Q&A. And the way we're going to do the Q&A is to start off with a question to Salam regarding his presentation. A quick 10 minutes, because we have overrun for time. So a quick 10 minutes, 2 or 3 questions we can take quickly around AI, and then we'll go to our panelists, because there are quite a few panelists over here. So to introduce this Q&A session, I'd like to welcome Mr. Rubas. Rubas and Mr. Namshid, these are 2 moderators for the Q&A. Hopefully the Q&A will be about 40-45 minutes. We are aware of the time. So our first panelist is Rubas. Rubas has also been a host, and he's one of our live wires in our EXL-UK, who is a civil engineer by background. He's one of the clever civil engineers who did his bachelor's in IT and went to do his master's in construction technology and management from IIT Delhi. So he's an IITian. So he's no mean guy. He's been 18 years in the construction industry. He focuses on project controls management. And also he's also involved actively in training, teaching, and is a STEM ambassador. STEM is Science, Technology, Engineering, Maths ambassador, supporting teachers and young people. So Rubas will be one of our main moderators. And I'd also like to introduce Namshid. Namshid Hashim is an IT consultant specializing in software testing and quality assurance, primarily in the telecom domain. And he has worked for British Telecom, Vodafone, Ericsson, Nokia, 3 UK, and Cable and Wireless. And is also ISAB and ITIL V3 certified. So both of them are around about London. So I'd like to welcome them to the panel. And I'd just like to introduce the Q&A session. Like I said, we'll start off with Salam's questions, just a few. And then we'll go on to our panelists. We will have the moderator's questions for the panelists, and then we can try to answer most of your questions. So we'll try to do that as quick as possible. You're aware, Salam's talk was so interesting and informative that it overran by a bit. So over to you, Namshid and Rubas.
Okay, sorry about overrunning it. As I said, it's not. No,
I think to be fair, I think it was exciting, and even a non IT guy, a medic like me, enjoyed it. So that was very, very good.
Okay, you can see that the receipt for the items has been already emailed to us. You can see my biscuit in there in the phone. So yeah, this is how it is working these days, guys. It's
Okay, great. So Rubas and Namshid, over to you guys.
Yeah, thank you, Dr. Riaz. Thank you for your kind words. So over to Mr. Salam.
Yeah.
I think one question, a simple question I will ask is, do you think an AI can beat a human intelligence?
Wow. My answer is no, because human intelligence it's not comparable. When I was showing the picture in the beginning, when I say, can you say which one is a shoe? Within not even a millisecond, it's a fraction of a millisecond. There are 2 shoes in there. But for a computer to work out, it is, it's going to be quite difficult. But it's going to get faster. But that is not the thing. I'll give you an example. I'm saying I like my mom more than my dad. So you can't just computerize it. Yeah. So because for computer to understand, it should be definable. Okay. And there are lots of things which we have. There are people kind of, this is my personal view. Yeah. There are people say, no, it can beat human being. These are specialized machine which can do one thing. and I'll give you an example. So the AI machine, the deep AlphaGo, when they were playing with the KG, if there was a fire in that building, KG will run, but the AlphaGo will not. Though it is very, very clever, it can only do one thing. And also the emotions, in my case, actually, I wasn't very good at it. I like what Mayavi more than Kapish, for example. I mean, they are the only characters I know. So how would you define it to a computer? It's impossible. So the brain, my dear friend, we are just underestimating what a brain is. It is an amazing machine, and you can't compare with anything. So yeah, the answer is no.
Okay. Namshad, are we having any more questions coming up?
I have a question, and it's my personal question. It's mainly because I think Salam is the expert on this. Are there any organization or body that ensures the ethical background of AI? For example, can AI ever make a fair decision?
This is a much debated area at the moment. There isn't a body specifically on that. In the UK, there is the Information Commission, and they will always look at, especially on the medical field. And there are. I mean, I'll give you an example. So if it's in robotics, people were in military, people were saying you can send a machine to fight, and the problem there is, the machine is going, and there is a little boy with a stick, and this machine, and that stick might look like a gun, but the machine is actually, it can't take it's only asked to target something which it finds to be threatening, and there's a good chance that boy will be, that little child will get killed. So it is. There is a big moral dilemma in all these areas, and also in when you go to a doctor, there is something called an empathy. When doctor touches and speak to you, there is an effect. I think Riaz can explain it more. When somebody touches onto you, there are things, some hormones, secreted, and it makes you feel better, even if the drug doesn't. Whereas if you go to a machine and put your hands into something and say, okay, you have a blood pressure, that connection is missing. So there is, there will be a body, surely, in coming time. But for the time, it is mainly done by the information commissioners, and everywhere it is basically the IT team. But there is obviously a moral dilemma in all of these things.
There is another question.
Thank you so much for that.
Salam, can I just comment on that, on the ethical aspects? I think there's a question on the ethical aspects. I think Rubas was going to touch on it. And in the healthcare field, there's a lot of discussion about AI, and I'm also actually going to get involved in one of these projects. There are serious ethical considerations here, because when it comes to privacy, data privacy, and then that sort of information, your body is your body. What are you doing with it? The brain is going to deal with it. So there are a lot of ethical issues, and in fact, there is an ethical body around AI that's being developed in the United Kingdom to look at these factors and watch the space, because if you have a robot doing an operation somewhere in America for a patient who's being operated remotely, somewhere in England, there are areas around the laws, not only the ethics, the laws around different countries around surgery. So it is quite a very, very complex area, when it comes to that. And I think because we're the start of AI, and we have a lot of medics and doctors now interested in AI, develop these sort of services. So like most things, you start somewhere and then you get there and you actually learn as you go. So I think that's what AI is about, isn't it? And I think there's a question here, Salam, for you from ethical point of view. Sorry, Rubas, I'm just going to ask the question why I'm on the ethical case. So AI can manipulate information, as did in the last US election, and create fake images, thus creating a serious ethical issue. So how is AI affecting human relations and relations with countries? So Salam, there's a question there.
So sorry, can you just rephrase the question?
AI can manipulate information, as did in the last US elections, and create fake images and fake news.
Yes.
So it creates
Yes.
a serious
Yeah.
ethical issue, and there is political.
Yeah. I mean, this is quite a hot topic. So basically, what's happening these days, including in India. So what's happening in these days is actually not. So in Trump's case, what's happening is he's playing with the media. So there are teams of people who look at the social media and just to extract what is coming loud and clear of that. So there will be billions of data fed into a system and find out that, what is the kind of expression or what do you call, if it is anger or, what is coming out, what is loud from that. So they get, these millions of ideas. Everybody is saying actually, oh, the current, the health system is really bad. Then the people, although they might support it or not support it, they will go with that, what is coming loud out of that, that study of the people. I mean, this is talking about, millions of people. So, and this is exactly what's happening in India too. Then based on that, you make the policy, which is not always going to be in the interest of the people, if you get what I mean. So look at the data, extract it, put some data scientist on it, and just make models out of it, and say, everybody is seeing there need to be a wall, and there is a big problem between the immigration coming in. That doesn't necessarily be the correct choice. And also, not everybody is using that. The people who is, unfortunately, the people using this kind of systems and shouting about it are actually the angry people. So what you get out of this is not always the right one, which is, what's happening in USA about the migration, and not only USA, around the world, including in the UK. The migration is not a problem for majority, but the people who who has some problem, they will always go to because they are already angry, they will always go to a system like Facebook or Twitter to say that I'm angry about it. And yeah, the politicians actually, they personally might not agree with that, but unfortunately they go with the flow. And that, which is exactly what is happening around the world at this point, and which is sad, because it might not be the interest of the people, but interest of the few who is angry about it.
Thank you, Salam bhai. Before we go to the panelists, there is one more question. I understand there are a lot of questions floating around. Maybe some of the questions can be answered during the panelist session. There is one question which was asked in the beginning. It is about, someone has launched a Masjid One project, which is designed to connect all the mosques across India. And this is going to focus on education, healthcare, microfinance, healthcare, women empowerment, and there are civil rights, etc. So they are querying how they can use AI for this project.
For AI to work with, to start with, you have to have abundance of data. Okay, so if you are looking at just starting with it, don't start with AI. Get the data first, because the machine learning, when I show the graph initially, you have seen one husband asking his wife, by next month you will be having 24 husbands, and in the masjid's case, that is what is going to happen. You only will have a linear graph. And what I would say is actually don't look at the AI yet. If you have a wealth of data from different masjids, different communities, different kind of masjids, I mean, obviously in India you have Sunnis, Mujahid, and this and that, and all of that. You come together, and then you have a wealth of data. That is gold mine. You are sitting on a gold mine. Okay, then you can put machine learning and deep learning and all to that, and then make some some predictive data out of that. But don't start with that, I would say.
Is there a predictive time scale for this kind of project?
It really depends upon how quickly you can get the data. If you have less than 5 gig of data, don't even consider it. Sorry, not 5 gig, 5
TB?
5 TB of data. Yeah. Okay. If you don't have 5 TB of data, don't even consider it.
Thank you very much, Salam bhai. I think
Salam, just Ruba, just one last question to Salam, because a lot of people have asked this question around AI. And after that, we can wind up the AI session, sorry, the Salam session, and then we go to that. So a lot of people are asking about, they are interested in doing AI. Yeah. And one of the questions is, where do they start from? Number one, studying about AI. Number two, are there any online courses or other courses about AI? Salam.
Yeah, online courses. I mean, see, if you look at the YouTube and if you search for AI, there are some really, I mean, there are some dodgy ones, obviously. But if you look for AI and look at specifically from Google and Microsoft and obviously Boston Dynamics, that's another one. They are in the robotics. And look at that, definitely search for, artificial intelligence. But from that, filter the one you think is, kind of responsible, like Google, Microsoft, and that would be a good start. And there is a portal called Udemy, UDEMY. And if you look at that, you can get a course for about £9, and sometimes register with that first. If it is quite expensive, don't buy it at that time. But then there will be sale on most of them. That will come to £10 in the UK. Most of the time, about £9. And at that time, buy it. Then you can keep it forever. And that is a good place to look. And there is something called another one called Linux Academy. Is pretty good, and they have some courses on AI as well. But if you are starting, start with the YouTube. YouTube is a very good place. And if you search for in Google itself, there are some really good books which Google themselves wrote about this one, which you can read half of it online itself without paying any money. So these are some places I would say, and obviously you can search Google and have a look at some of that, some of the white papers which they publish.
Okay, thank you, Salam bhai. I think it's time that we move on to the other experts. We have experts on various fields. So like Dr. Ria said, our goal is to maximize your understanding on these subjects within the time frame we have got. And I'm very sure that all of our panelists will agree that there is no such thing as a silly question. So I'm going to share my screen, and I would like to introduce our first panelist, Mr. Syed Kandambilakil. He's a data specialist with 16 years of industry experience after his master's in computer applications. He has worked with renowned companies like Sony PlayStation, SSC Energy, Hiscox Insurance, Asher's Law Firm, Veolia, Norgine Pharmaceuticals. And he is also an IBM certified developer and has dabbled with mentoring and teaching in the past. So, Mr. Syed, for the benefit of a non-IT person like me and others who are new to this field, can you please tell us what is a data science?
Thank you, Rubas. I hope you can hear me well.
Yeah, that's audible.
Thank you. Yeah, that's a good question, and it's very tricky to answer as well, because if you go through the definition of data science, you can see different from a one-liner to a complex definition. Well, one of the best definition I have seen is from Casey Kozikov. She is a chief decision scientist in Google. It's a one-liner actually. She says data science is the discipline of making data useful. So in that way, whether it's if your data is small or big, if you can make it useful through some process or some disciplines, that's AI. Sorry, that's data science. But if you look at a bit more, you can see many pillars in it. Some of them like data mining, machine learning, like NLP, natural language processing, statistics, and mathematics and visualizations as well. So sometimes you don't use all of these. Sometimes you use some of these. Does that make sense, Rupas?
It does, which actually kind of takes us to the next equation to this. The research, let me share my screen again. And I would like to introduce Dr. Azim Shah Tachampoil, who is a PhD computer science, who has done his PhD computer science at the University of Hertfordshire, and who has also got his master's degree in electronics at CUSAT. He has got an electronics and computer science background with experience mainly in industry and research. And his PhD research was in rehabilitation robotics, and which was involved in exploring the adaptation of human and robot interaction systems based on muscle fatigue. And he has published few international conference and journal papers in the field of human-robot interactions, signal processing, and machine learning. So, Dr. Azim, as with the recent outbreak, I can understand there is definitely a spotlight. Let me change the spotlight to you. Can you please comment about the current research, mainly in the field of robotics and AI in medical applications? I understand Dr. Riaz was also kind of interested, and part of it might be answered by Mr. Salam, but can you please put your thoughts onto it? You're on mute.
Azim, you're on mute.
Rubals, maybe can you
I'm just
come back if it takes longer?
Dr. Azim, can you please try now?
Can you hear me?
Oh,
Can
yes.
you hear me now? Can you hear me?
Yes,
Yeah,
we
it is
can hear
audible.
you.
It is audible. Yeah.
So, I wasn't able to unmute myself. So, yeah. Thanks for giving this opportunity. So basically, I understand the question is regarding the robotics and AI in the medical applications, right? Some part of this has already been addressed by Dr. Riaz and others. So, in short, this is really a kind of big research area where the robotics, which is actually a hardware counterpart of AI, being used in medical applications. The area which I've been working on is rehabilitation robotics. So what I've come across is the various universities currently into the usability of technology, which makes use of the AI algorithms and so on. For example, in association with the hardware technology like haptic sensations, virtual environments, technologies using AR and VR products, there are equipments which makes use of the signals originating from human body. For example, the electromyograms, which are coming from the muscular patterns, and electroencephalogram signals, that is EEG and ECG signals, and the equipments which are wearable to a patient. For example, these signals can be used to adapt the training environments and so on. So it's a huge research area. So recently I've come across devices which are really you can wear it like a watch, and you can just make use of this device to access a game. So this is something which can be used for training stroke patients, for example. So if you need to give continuous repetitions of training for stroke rehabilitation, where people need to move their hand continuously over different intervals and for many days and so on. So we don't have to really get the assistance, the physical assistance from a therapist. Instead, they can equip this device in their home, the patient's home, and this device can be remotely monitored by a therapist. That means here we are reducing the need of a physical presence, and we are better making use of the expertise by the therapist, actually. So what's going to happen in this scenario is that the device, maybe in this case you can say it's a robot, this robot assists him to perform many repetitions in a adaptive way, the robot can understand how the patient performs, and the robot can modify its assistance based on its learning. So the AI program will be running in the robotic controller. So these are all like some sample use cases. There are plenty various other things which many people here will be already aware of. So this is in short, actually. So does it answer the question?
Part of it, yes, Dr. Azim, and I'm very sure there will be a few more questions coming into the chat
Just to
room.
add on to that, I was watching a video. So in your hand, there is prosthetic hand. Actually, there is a big, research going on. Actually, the problem is actually when people with the prosthetic hands, if they take on, for example, like glass, there's a good chance it's going to break, because we can do this, and we take this for granted. And a robotic arm to do like that, that is 10 years of research. And this is what somebody's question was asking earlier, actually, whether it can beat our brain. Absolutely not. Because just doing this, we take for granted. And, as I said, it takes years of programming to do that. So when you're picking something, for example, if you're taking a glass, you put a certain set of pressure in there. But if you're taking a hammer, a sledgehammer, you put a different pressure on there. If you have a prosthetic hand, it doesn't have sensors on that, initially, but that's what I was talking about. So what they have done is they put some sensors on that. Then if you touch on that, it will understand it's a glass or it's a sledgehammer, and based on that, it adjusts the pressure on your hand. So it has got individual fingers, and you can take on that. And that is a really interesting area for me as well, because if you think about it, it's really, really amazing. Then only you would understand, what our brain is, what's happening, when that is, the brain will still have some information going through. Then they will put a chip in there. So that chip will, the good thing is actually in our case, the message is very, very feeble. The machine can't hear it. And they have to amplifier to amplify it. Then they'll just move the hands just in chip. So that's an interesting area in the medical field, this prosthetic limbs. And
Salam, I'll come in there. I think rehabilitation medicine is a process of brain learning. Forget about machine learning. The brain itself is learning from the various neurons for rehabilitation. That's why when you get paralyzed on one side, your brain constantly learns. Your brain cells and neurons constantly learn about the process. So imagine that the brain cells are already learning, and then now you've got a computer to do it via deep learning. So that's why it's such a complex process. It looks very simple to the common man, but because I've got an interest in rehabilitation, and it's very, very complex. And people are developing prosthetic limbs. It takes about 15, 20 years for nerve regeneration. But things may change. Computer may learn, the brain may learn. The brain needs to learn first to let the computer learn, if you know what I mean. Yeah. So it's a very, very interesting area. So I think, thanks, Salam. That's very useful. And I think over to you, Rubas, for the next person.
Yeah, thanks for the wonderful insight, Salam Bhai and Riazka. I think that is what Dr. Azim touched upon, and I think it was one of his PhD research also was in rehabilitation robotics. So I would like to move on to our next moderator, Mr. Namshit. Mr. Namshit, can you please unmute yourself and introduce our other panelists?
Yeah, thank you, Rubas. Rubas, could you bring back the slide, please? Okay. I'd like to introduce Mujib Parambat. So Mujib is a software development manager who has specialized in automotive applications and worked in the industry for over 20 years. He's done his engineering, Masters of Engineering Automotive Electronics from Germany, and his graduate in engineering in electronics. Mujib is responsible for some various time-critical application development within the automotive domain, and with key interest in AI-based computer vision application, such as the mirrorless car, which is going to be the next big thing in the automotive industry. So, Mujib, I've got two questions for you. The first one is, what is computer vision?
Okay, this is just continuation of Salam's. Can you hear me right now?
Yes, I can hear you.
Okay. Computer vision is a software development manager who has specialized in automotive applications and worked in the industry for over 20 years. He's done his engineering, Masters of Engineering Automotive Electronics from Germany, and his graduate in engineering in electronics. Mujib is a software development manager who has specialized in automotive applications and worked in the industry for over 20 years. He's done his
Yeah, you're
Loud
okay.
and
You're good
clear.
to
Okay. See, this is just a continuation of what Salam has said. You might have remember what Salam said in many places about AI playing with images, videos, etc. So normally a computer see an image just a set of pixels. It cannot recognize whether it is a person or a thing or whatever it is. So computer vision is a part of the science, a part of engineering, where it says to make these pixels into a meaningful thing. So you can apply AI on top of computer vision, so make it more and more useful. Also, you can do without the AI. So it's like data, and you can do data analysis, as Siad said earlier, that you can work on data without an AI. But if you apply AI techniques, it gets more and more useful. In the same way, image can be processed and made useful without an AI. Or if you apply AI, it becomes more easier, and you can do a lot of things. So it is some of them Salam has already said about convolution and polling, etc. This will come as a part of computer vision. So if you learn more about the computer vision, you can play with image and make sense. I just want to show you my screen and give you some introduction. I'm sorry if this involve a bit of coding, so I don't know if somebody who is not interested in programming may see this a bit boring, but I just take you through this. So I wrote recently a program which is in the GitHub. You can go to the GitHub and have a look on this. It is shared publicly. So in this, if you run this program, this is used to detect an age from a person's face. So I used OpenCV. This is OpenCV's. If you go to the website, you can see OpenCV here. This is developed by Intel. It's available as open software. You can use it for making most of the image processing. So if you want to detect age from a person's face or detect an emotion, as earlier discussed, you can also use Google libraries, which you just send the picture and get the emotion back. But you can do it yourself by using OpenCV. This program is purely using a Raspberry Pi and OpenCV. You can run it through. I'm using some Amazon library as well into this. So that is purely just to give you a brief idea of what is computer vision. You have another question?
Thank you, Mujiba. That was a great insight into this.
And Namshid, let me just add something. I think maybe this is related to computer vision, but in the field of medicine, what is happening is we are having the machines to learn our the X-ray images, radiology images. Yeah, looking at the images. So what is happening? There's a trial going on in England at the moment when the machine we are putting a lot of normal X-rays, chest X-ray, normal chest X-ray into the machine, and the machine is learning. So they're having hundreds and thousands of images that has been put in. Now, what is the application for this? The application for this is once you put that machine in the computer, normally what happens now, it gets reported by a radiologist. So what should happen is the computer should actually pick up a normal X-ray. So automatically, so it actually helps us to do things very quickly. That's just one, I think, not if it's computer vision, but one of the applications of AI in healthcare. I don't know if that's...
Yeah, that is a computer vision, Riaz. And the DeepMind, that is a Google product, it beat the Go player that Salam said earlier. Google has given a set of X-rays to DeepMind, as well as a set of X-rays to the radiologist. And this happened in January. The result was that the DeepMind robot picked up breast cancer more than what the doctors picked up. So that is you can see there is a news in Bloomberg about that.
Thank you, Mujib. Namshid, please continue.
Yeah, thanks for that insight, Mujib. I've got one more question for you. Could you shed some light on how does artificial intelligence improve computer vision applications?
Yeah, as I said earlier, the computer vision is making sense of the image or a video for a computer rather than a pixel. And if you apply machine learning techniques, it can improve a lot of predictions. So, for example, if Intel came out a new technology now, what it does is maybe interested to Rubas as well. So they run a drone through the bridges, and it can detect cracks on the bridges up to a length of 1 millimeter size. So the drones fly through the bridges, and it can scan the bridge structure. And if it does every 3 months or 2 months, it can detect the change between two previous images and see any cracks or any maintenance required. This will save a lot of manpower because detecting may be easier, but climbing to such a huge structure maybe takes time and a lot of. So Intel's drone is available. You can see that they are also published the report on that. So what Intel does is they applied the artificial intelligence and computer vision technology together and produced a software which can detect very, very small cracks on buildings, bridges, and etc. So that is how the AI improve the computer vision.
Thank you so much, Mujib Bhai, for that. Rubas Bhai, can we go back to our slide deck?
No, one more. Yeah.
To our next panelist. Okay, I'd like to introduce Faisal KP. So Faisal is an electronics and communications engineer, currently working as Connected Autonomous Vehicle, CAV, leading actively in the Innovate UK funded research projects in the area of smart connectivity and digitalization, one of my favorite areas. He has very good experience in full life cycle of embedded systems development and is responsible for driving many strategic initiatives in the automotive electronics, including development of solution accelerators for infotainment and telematics. Faisal, I've got two questions for you. The first one is, how will artificial intelligence change the future in the area that you're working on?
Thanks, Rubas. Can you hear me?
Yeah, we can.
Yeah, good questions. As you see now, this AI is happening very much. Of course, in near and far future, the AI is going to be happen in much of the field. Especially, I can see that the health sector and educational and transport industry, the AI is going to be happening, and of course, that will be one of the immediate visible for us. As Salam is already shown so many demonstrations how it is happening. It is really happening, and for me or everybody, AI is not a new. If you look on many years ago, when the market introduced a fully automated washing machine, that could be the first kind of a implementation of the neural network in the industry. So that means AI is happening many years ago. It's gradually happening, but of course, in some areas, the AI is going to be happening very exponentially. And as well as, if you think about how it is affecting in your individual life or in a society or in the business field, of course, you can see a different use cases of AI. So in nutshell, AI is happening in your individual and in the society and as well as in the business areas everywhere. Yep.
Okay, thanks for that insight. I have one more question, if you may. Autonomous car. I know we have some tests going on in the UK and these tests have been going on in the US for some time. But do you think that the autonomous car will become mainstream in our day-to-day life?
It's a good question. I would say it's again depends on how each one of you are dreaming about an autonomous car. So autonomous car is a dream. I would say answer is yes or no, because if you think about an autonomous car, that means a car without a steering wheel, without a brake, that can fly over, on the traffic jam. It could be a fantasy kind of stuff. Somebody is thinking about a autonomous car is like that. In that case, it's a long way. For other ways, if you think about a car, which can do some of the autonomous driving in a controlled environment, for example, motorway, that's very much possible now. But the most challenging part is that how we can run an autonomous car in the urban area. Of course, if you drive in a car in a city environment, we are facing a lot of issues. For example, we need to understand how many obstacles are going on the road, the pedestrians, the kids. There are a lot of signs. The similar kind of challenges are going to happen in the autonomous car research. I would say, that is gradually happening. If you look on the autonomous car deployment, autonomous car deployment is grouping from a level 0 to level 5 autonomous. I would say, in the market, currently we are in level 2 category. Most of the vehicle OEMs are researching towards making them vehicle capable to level 3 and level 4 autonomous. That may happen in next 5 to 10 years, but it will take time to do a complete autonomous car. Is that answer the question?
Yeah, it does. Thank you. Any further questions for Faisal?
Just to add on to that, again, it really depends upon what you define by an autonomous car. I mean, if it is, the question was whether it is here or not. I would say here. You might have seen the car outside. The one I went to London yesterday morning, and I would say I was driving it myself probably about 20% of the time. The rest of the time, the car drove itself. And I have taken a video of that. Let me just see. I can show you 1 second. If I quickly, if I can.
Yeah, while Salam is doing that, if people have any more questions, you can do it 2 ways. You can just raise your hand on the chat option, and then you can ask the questions. If people have any more questions, or you can type. I think if you want to ask questions, please raise your hand and we can pick it up. Yeah.
Yeah, I think what Salam is showing is that, the Tesla autonomous car, I would say it's again depends on, it's one of the autonomous feature. For example, one of the autonomous features we are currently using in our day-to-day life is called the adaptive cruise control and the lane keep assist kind of features that is very much available in most of the, the premium vehicle now.
Faisal, if you can explain what is level 1, 0 to 5, then people, I think, understand.
Yeah. So basically level 0 and level 2 or level 1 at 2 features, it's already there. Our car is having so many sensors fitted, for example, radar, camera, just consider a car, just as a human being, in the car. Now we have how a human being is seeing an object on the road by eye. Similarly, we have cameras on the car, and as well as we have a radar in the car. By using this kind of sensors, we can do, for example, emergency braking. If there is a car in front braking heavily, the car following that car can do emergency brake by using the radar, based object estimations. And as well as, the car can, recognize speed sign in the road, as well as in the map. By using that one, based on that information, car can adopt a speed automatically. That's called speed limiter. And as well as, especially in the motorways, if you put our car on, fully or ACC mode, that's called adaptive cruising mode, the car can follow a car in front, the speed that's set by a driver. That means driver don't want to, they can lift their leg from the accelerator, the car can follow in front of the car. That's called ACC features. So these are the features, the level 2 features. That means these features are very much possible via supervised mode. That means driver should, keep his hand on the steering wheel, and the car can drive automatically, but of course it's needed supervision. That's the level 2 features. If you go to level 3 and level 4, it's a kind of a unsupervised, the mode. The live driver can lift the hands from the steering wheel a couple of times in level 3 features. And especially level 4 and level 5 mode means, the vehicle should, can drive in the city environment with a fully unsupervised mode. The most challenging part of, deploying this sort of technology is that technologies are there, but of course, there are a lot of liability in terms of if you fail for a single cases, that make a lot of liability for the vehicle OEMs. That means it will take a time to test and make this system reliable to the society. It will take many years to go, especially for level 5 and level 4 autonomous driving.
So what Salam has just shown is, Faisal, is it level 3, isn't it? 3 or 2?
What I think what is shown is like a line keep assist, isn't it?
Yeah. So I think it is a level of bit higher feature one, level 3.
I would say it's a kind of features between level 2 and level 3.
So yeah, actually autonomous car means fully autonomous means level 5. So what we have seen now is up to level 3, maybe 1 or 2 steps from level 2.
Hello. Sorry, Mr. Hatim, can you mute, please?
Coming off mute. So I think it'll be better.
Mr. Hatim, can you mute, please? Otherwise, we have to mute everybody, then we have to unmute all. That's the problem. Yeah. Can you, Mr. Hatim, can you mute yourself, please? Yeah, go on.
Yeah. So for a fully autonomous car, there is a long way to go. That's what Faisal said. What we have seen now in the market is maybe level 2, so that you can see, or maybe very close to level 3. So you can see how long we have to go to reach a fully autonomous vehicle.
I think Mr. Nizar has he has raised his hand. I'm just going to unmute him. Mr. Nizar, Mr. Abdul Nizar.
Assalamu alaikum.
Wa alaikum assalam.
Yeah, I have one question about the autonomous car. So how far the infrastructure plays the role? Because, okay, all the while we have been talking about the car itself, but the infrastructure, the road conditions and other, the traffic situations and all those aspects, how it is taken into account while designing this autonomous car?
Okay, I can answer that question.
So Faisal, let me put a disclaimer. That's my brother from Riyadh.
Okay.
Yeah. Okay, Riyadh.
Okay, thanks. I can take that question. Infrastructure is going to play a bigger role in the autonomous car, especially for connecting a car into the infrastructure, especially for traffic light. I would say, take an example. There is a feature called GLOSA, that's called Green Light Optimal Speed Advisory. That means nowadays we have the green, red, and amber color in our traffic light, right? That means normally, what is happening today is that whenever you're approaching the traffic junctions, you have to understand what traffic light it is. Then either you have to stop there or you can pass over the traffic junctions, looking into the traffic light. Imagine there is a situation that you came to know about the traffic light phase information 1 mile away from your vehicle. So that means vehicle can understand at what time your vehicle is going to reach at that particular traffic point. Accordingly, the vehicle can adapt a speed in such a way that you can avoid a stopover at the traffic junction. Either the vehicle is going to say to the driver, or it will increase your speed of the car to avoid the stopover at that particular traffic junctions. That means if the vehicle can get a infrastructure related information in HUD, they can make some decision in fast. Accordingly, they can adopt some decisions. That is one of the example. And other example could be in near future,
we can see that the vehicle can talk to other vehicle on the road. That's called V2X communications. That means, as I said before, at this point, we don't have any hearing capacity in our car. But of course, human can see each other by eye. They can listen to what other people are talking by ear. Similarly, we are going to fit an ear on the car by using a technology called V2X. That means whenever we have the technology in place, a car can see beyond the camera. Car can see beyond the wall, especially for if two cars is coming to an intersection. Imagine there is a big trees and in the buildings in that intersections. The car can see what is really happening behind that building if there is another car is coming up. So according to that technology, we can avoid a lot of accidents on the road. The car can understand, they can talk each other, what speed they're coming, what they're doing on the road, if there's braking, if they're doing any handbrake. So based on this sort of technologies, a lot of accidents is going to be reduced on the road. So there are a lot of things are happening, in these sort of areas, especially the communication from car and communication to the cloud and communication to other infrastructure and the vehicle, and make a lot of changes. Is going to be happening a lot of changes. Whenever we have the smart cities of all the infrastructure should be communicated into the car. Especially in the parking areas, all the parking sensors, everything is going to be communicated to the car.
Okay, thank you, Faisal. I think there are a few more questions. I think I can see one question here, which was there about AI. I think it's for Salam and the entire panel. I think all the panelists can answer. Why is there no AI in India? There's no autopilot in India. We can't see Alexa in India. Salam, why can't an Indian have a lifestyle like you? That's the question.
Alexa, there is no, I don't think there is anything preventing Alexa to be in India. The only thing might be the internet connection, because it can come and go. If for Alexa to work, it has to communicate. That machine is just, just to pick up your noise. And it has got a mic and a speaker, that's all. It has to communicate with the server all the time. Okay, so if your internet connection is good, it's not gonna work, okay?
But who said Alexa not in India? Are you sure? Or I think it is available in India.
I don't know. There's a question here. I think it says reconnecting. Yeah. Somebody called reconnecting. Yeah.
What was the second part?
I mean, it's the same thing. Autopilot. Why is it not?
Autopilot. As somebody said, the condition of road is actually a big element, because if you look at my video, it is kind of right in the middle of those two lines, and that two lines is actually, it has got about, loads of cameras on the front. So it kind of scans these lines all the time. If that line in India, people kind of move like that. The driving is like that, isn't it? It's not straight line. So even if there is a line, it's going to get, worn out quite quickly. If you don't have those kind of lining, so yes, somebody asked, infrastructure is a very, a very important aspect of self-driving cars. So if you don't have a line, and if there is a big potholes and people cutting left and right, it will be quite difficult. It doesn't mean actually you can't drive it. It will be able to drive, but it would need your assistance as well. I don't think we can drive it just like I was driving on.
Yes, add on to Salam explanations, I would say the rules on the road is very critical for the autonomous car.
Yeah.
Of course, especially in India, we don't have any rules on the road. Of course, we have a rules, but it depends on how the people are obey that particular rules. That make a lot of the simplicity in challenges for deployment of such vehicle on the road. That exactly the challenges in the autonomous area also. How we can build an autonomous car with and without rules on the road. If you have a strict rules on the road, of course, it's very easy.
Okay, thank you. I think we just got a message saying one of the participants said they have Alexa at home in Kerala. There we are. So there